Om Shri Ganeshaya Namo Namah. Greetings to everyone world over, all our brothers and sisters across the globe, wherever you are. We extend you a very warm welcome. It's a green morning, green afternoon, green evening. This I have learned from Professor Sushil Gupta ji, who is a principal in Agra. One day he told me, Dr. Sharma, instead of saying good morning, good afternoon, good evening, why not we should say green morning, green afternoon, green evening? And I just followed him. And I really feel that everything looks green when you talk green, when you think green. एक दिमाग में इमेज आती है. आज क्वांटम रेडिनेस की जब बातचीत होने जा रही है और हमारे साथ मेरे मेंटोर जिन्हें मैं बहुत ही मन से, आत्मा से, बहुत आदर सत्कार से मैं हमेशा निवेदन करता हूं कि आई विश टू लर्न समथिंग फ्रॉम यू. Professor M.M. Pant, founder LMP Education Trust and the former Pro-Vice Chancellor of IGNOU. Saturday, 17th of June 2023, evening in India, morning in Canada, America, Latin America, afternoon post-lunch in Europe, and of course, Southeast Asia, ASEAN, a little ahead of us. Before they go to sleep, they are going to enjoy the quantum readiness, and people in Middle East a little before us might be enjoying their evening tea, and Central Asia, Mauritius, Africa, all the places wherever we have got our brothers and sisters, we extend you very warm welcome Bharat se. क्वांटम रेडिनेस आज हम लेकर चलेंगे प्रोफेसर एम पंत जी के साथ. Before I take you to my mentor, we wish to extend you a very warm welcome. And there's something very interesting which has come from our chamber. Now, chamber, of course, is working towards service industry, but we have got the patent and we have got the trademark and we have changed our finishing school post-pandemic to digital inspirational lab. दिल से दिल जुड़ जाए और इसकी फॉर्म भी हमने दिल रखी है, डिजिटल इंस्पिरेशनल लैब. और कोरोना के बाद दोबारा से एक्टिवेट कर रहे हैं because the industry which suffered maximum during the pandemic and post-pandemic still suffering because we haven't got the inbound tourism to India, tourism, hospitality, and airlines. And in 2001, my another mentor, Sri B.K. Goswami, 1960 batch from the UP cadre, he was DG Tourism, he was Secretary Tourism. He interviewed me before I moved on deputation to the Ministry of Tourism, Government of India. I still recall, in 2001, he gave me the vision. He says, India has got Travel Agents Association, Tour Operators Association, Hoteliers Association, Restaurants Association, High Network, all the Travel Trade Association. Why not we should have Educators and Skill Providers Education Forum? And that was the feast. I still recall December 2001, ladies and gentlemen, Forum of Educators and Skill Providers for Tourism. Our annual convention is going to take place now, post-pandemic times, on 5th and 6th of October. And we would be extending a very warm welcome to Professor Pant sir also to meet the entire fraternity of the service industry together on a common platform. All educators will come. We are hosting this in the city called Bhubaneswar, that's in Odisha, and that's going to be at Sandy Towers Hotel. Anyway, we will give you the details of that a little later. Let me introduce my mentor and the speaker of the evening, our guest. Professor Pant sir is PhD in computational physics with a professional degree in law. After a long innings of 50 years plus, when I talk about as an academic researcher, lawyer, and education entrepreneur, he's now exploring the new pedagogy, technology, and curricula for the future with focus on the period which is heralding the fourth industrial age. In our previous programs, if you'll see, he has discussed what was the first revolution, second revolution, third revolution, and how the fourth industrial age. His special focus on mobile, WhatsApp-based lifelong learning, transcending traditional education and blending personalized and social learning. हमेशा कहते हैं there should be a self-learning, self-paced learning, and our deep gratitudes to him. He ran a special program for entire Northeast, all the 8 states, B.Ed teachers Students, those are going to become teacher. He ran the special program for them. You can see it on @ICSI India Live. When you go onto the YouTube channel, you can see everything over there. He has been a faculty at the MNIT Allahabad, University of Western Ontario, Canada, and IIT Kanpur. He was a pioneer in computing at IGNOU as Pro-Vice Chancellor. Some of his current educational initiatives are introducing quantum principles at school, preparing teacher and learners for the age of artificial intelligence, and learning 3 to 1. People, those are in group, learning 3 to 1. My deep thanks to all of you. You all are very supportive. And I was just discussing, off the curtain with Sir that I come from the service industry. I dedicated my last 40 years in service industry. I hope Professor R.C. Sharma ji and Professor M.M. Pant Saab would give me an opportunity somewhere post-August to speak on service industry on that forum in Gurugram. I had gone there. I attended that program. It's scintillating and it's very, very captivating. Education in the third decade of the 21st century. Professor M.M. Pansar is promoting the ideation, development, and delivery of the education product and processes and services for the next generation learning space in the post-internet world. In tune with the emerging knowledge economy, he's exploring the creation of the quality knowledge products and ways of enhancing the productivity of knowledge workers. His vision is to promote learning, thinking, and caring to achieve the higher goals of human existence and flourish, prosper, thrive, and be happy and fulfilled in the rapidly changing future to be future ready. His personal commitment is for enhancing human capital through the personalized and inclusive education and transforming teacher training to foster the development of a professional group of independent educators. His contribution in the field are proposing new constructs such as learning metrics, learning kinetics, educational informatics to enhance learner motivation and the yearning to learn, learning to think, developing ways of monitoring epistemic development to achieve the required goals and outcomes. He is leading the formation of a new business landscape for education, having founded a very successful enterprise and encouraging several startups in finding their way in the new maze of educational opportunities. Ladies and gentlemen, today is Saturday, and then of course, you all are aware of every moment and every day, more than 6,000 to 7,000 thoughts pass through our mind during the daytime before we go to sleep. And whatever our mind can conceive and believe it can achieve, let's move together towards quantum readiness with Professor M.M. Pansar. In a very humble way, we wish to share with all of you that having started this special Zoom session series on 25th of March 2020, when there was a complete lockdown, we have not taken a rest even for a single day. There is no Sunday, there is no Monday. Every day is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We have completed 1,993 Zoom sessions, all dedicated to humanity. कल मॉर्निंग में आपकी मुलाकात 9:30 बजे होगी प्रोफेसर सत्येंद्र धीमान जी के साथ, एंड ही वुड बी टॉकिंग अबाउट श्री रमन्ना महर्षि जी, विद्या से अध्यात्म विद्या की ओर, tomorrow morning at 9:30. And every evening on Sunday, we bring a special program for you, Ayurveda for Global Wellness. And we are going to tomorrow talk about health and wellness through Ayurveda. And every Sunday in the evening, we take you to non-resident Indians. Tomorrow we'll be going to Canada, and you will talk about non-resident Indians' contribution, what all they want to do, they can do, they will do for tourism, for Indian education ecosystem, and our service industry. That will be tomorrow evening at 8 o'clock. Northeast is very special to my heart, because when I got into the army, my first rank, my first salary, my first uniform, my everything first, which I started with this life, that was from the Northeast. I dedicate myself completely to the Northeast part of India. and Professor Dr. S.P. Singh, the Vice Chancellor, Royal Global University, Guwahati, is going to do a program with us on Tuesday. That is NEP 2020 as socio-economic growth engine for entire Northeast India. With these words, ladies and gentlemen, join me in extending a very hearty welcome to Professor M. Pant, sir, my mentor. It's a treat, it's a pleasure, it's a treasure, and it is something which I wish to preserve in my life whenever I listen to him. All yours, sir. The world is yours. Everything is yours. Let's move on this particular journey and let's hear your sermon.
So thank you, Dr. Gulshan Sharma, and it's a pleasure to be here. And as you would have noticed, the topic is a little different from other mainstream topics where people are talking. But I will tell you first the trigger of this topic. The trigger for this topic is that if you have seen, ChatGPT was introduced in November 2022. In a couple of months, it took the world by storm. And now there are so many stories about jobs being disappeared, humans becoming irrelevant. There will be no work to do, and so on and so forth. And what I wanted to say is draw attention to something. Today is something, there are many more, that there is a lot more to do. It is not what we've been doing is the only thing. And this has happened in the past also. Everything that was done by way of technological progress and automation meant that some people who were doing their job no longer did their job. And I'm not getting into that. Time is short, so I want to get straight onto the topic that I want to talk about. And my format is going to be that I will speak for about half an hour, introducing the topic and telling you about the topic, and then respond to your questions, comments, and observations. I'll begin with my story. For example, Dr. Gulshan Sharma, in my introduction, one of the very first lines says that I am a PhD in computational physics. Now, when I was doing my PhD, this is the late 1960s, 67, 68, and so on, I was using computers, and that's why it is called computational physics, to understand the properties of solids. You know, matter, we say solid, liquid, gas. So I was doing solid state physics and using, don't be surprised, using quantum mechanics to find the properties of solids. Now, when I was doing a work like this, so many people would come up to me and say, what does all this have to do with Mr. T.C. Mitz? You wonder who is Mr. T.C. Mitz? Mr. T.C. Mitz is the celebrated man in the street. I'm using T.C. Mitz because I could have said in Hindi, like Dr. Gulshan Sharma mixed a lot of Hindi, but today saying Aam Aadmi is seen as a political statement. And therefore I'm saying, no, it is the man in the street that I'm talking about. And I had no simple answer because I knew I was doing physics and this is high-end physics. It has of some interest to people like me. It will help, maybe I will become a physicist later on. But what does the common man have to do with it? But today I have an answer. Today I have an answer which all of you will appreciate. It is the GPS. The GPS is keeping that man on the street on the right street. Which street he should go to, when should he take left turn, right turn, all that the GPS is telling. And the GPS has the highest science in it. It has first satellites. You know, the first satellite was put up in 1956. Today, there is a whole range of satellites which are receiving signals from where you are. And they're looking at two things. One, the time of all these signals, and the time difference between going a few feet on the earth is so small that you need what is called an atomic clock. It is a cesium atomic clock which measures the time and which is all a quantum phenomenon. To calculate the distance, it tells you 10 minutes, 20 minutes, 7 kilometers, this, that. It uses Einstein's general theory of relativity, for which he proposed around 1920, then it was verified and so on. Now, things like this, Einstein's general relativity, quantum mechanics has become part of day-to-day life when we are using it in the GPS. I'm sure you're not surprised that the transistor that you use, the TV that you use, the computer that you use, they were all based on quantum mechanics, the semiconductors, everything, and so on and so forth. So we've been using quantum systems, but largely they were inside and you didn't have to worry about it. Now the new technologies are going to be such where you will see the quantum phenomena before yourself. And if you think quantum is something which is happening in big laboratories and so on and so forth, of course it is happening. You need big laboratories to do study in a scientific manner, but quantum phenomena are all around you. And one of the simplest ways for you to see a quantum phenomena, and Dr. Gulshan Sharma had told me when we were informally discussing before that some people say, this is your time for doing cooking in the kitchen and so on and so forth. So I will give you an example of a quantum phenomena in the kitchen. Now, when you switch on your gas flame, suppose you have a gas on which you are making your cooking, normally the flame will be blue. Now, take some salt in your kitchen, put that salt on the flame, the color of the flame will turn yellow. And the full explanation to why it becomes yellow from blue is quantum phenomena. And the quantum in it is that salt is sodium chloride, and there is sodium there. Sodium ionizes, and the lines of frequency that it has is in the yellow thing. That is why you see on the street the sodium lamp, they are yellow lamps. All that is basically quantum phenomena. And not only that, almost all kinds of things emit specific lines of radiation with which we can even detect that phenomena. And I will tell you later on that this is the phenomena, I mean, not this, but a similar phenomena called Raman scattering, for which Raman got the Nobel Prize, is used for detecting all kinds of chemicals, etc., because of this spectrum. The point one is saying is that quantum mechanics is so far the best theory that scientists have as to how the universe works, how the world works, and therefore it is everywhere. Although physicists studied it more, they introduced it, but the laws are applicable everywhere. Just like the theory of gravitation is applicable everywhere, whether you're doing it in a physics lab or on the field, it is everywhere. And just like the theory of gravitation also applies in, let us say, agriculture to the extent that a ripe fruit will fall to the ground, quantum mechanics also applies to agriculture. And I will share with you the phenomena of photosynthesis, on which all life depends, is a quantum phenomena. And as you would have known, and I will elaborate if some people ask, a light particle called the photon interacts with the chloroplast of that plant to generate glucose, oxygen, energy for the plant, and oxygen for us. So we are all living on quantum. And one more example, which is not a laboratory example, but you know how the energy comes to us from the sun? That is also a quantum phenomena. It is the hydrogen atoms which fuse together to create something, and energy is released. As you know, it was done in what is called the hydrogen bomb, but bomb is a sudden explosion. The sun is a continuous source of energy. All our energy eventually comes from the sun, and that is because of what is called thermonuclear fusion and is a quantum phenomenon. I just wanted to begin with this, and we'll say more about it, is that quantum is all around us. So what do we mean by quantum readiness? Quantum readiness is at different levels. One is at the national level. Is the country ready for quantum? In fact, again, Dr. Gulshan Sharma had posed this question to me in the informal thing. And I'm happy to inform you that the country has announced, and you can Google for it, or you may have read in the newspaper recently, there's a national quantum mission which has been announced by the government, and not just announced, 6,000 crores have been laid down as the budget allocation for that, for India to be able to achieve quantum ability, quantum readiness, whatever we want to call it. And this is why, for young people, this is the greatest career opportunity today. Why it is the greatest career opportunity? Go back, 1960s. Why did the IITians become so important? Because while the others were studying traditional subjects, even engineers, again, Dr. Gulshan Sharma will recall, engineers were using slide rule. At that time, IITians started using computers. The IIT Kanpur had an IBM computer from US. The IIT Delhi had an ICL computer from UK. IIT Chennai had a Siemens computer from Germany. IIT Powai had a Russian computer, but they had all become computer literate. And that's why today they're head of Google, they're head of IBM, they're head of this, etc. Similarly, the young people, even right now from school, who will become aware of computer things. And today, there are so many self-learning opportunities also, online learning opportunities also. They become familiar with quantum, they will have a bright future. So this is one at the national level. The other level readiness will be at the school level. Today, most schools don't teach quantum physics at all because in the CBSE, it is not there, maybe one chapter, two chapter, etc. So schools who can create this, just like schools are now teaching about AI and are teaching about this, if they start teaching about quantum physics, quantum biology, quantum mechanics, quantum engineering, etc., whatever, the students will be ready to learn more elsewhere. So during the school, they get an introduction to it, but they will learn it when they go to university, but they know that this is what I can go and do for. And the third is at the individual level. So nation, school, and individual. At an individual level, you can already start looking at. Today, if nothing else, go to ChatGPT and ask, how do I learn quantum? ChatGPT will tell you something. You say, what is a good book on quantum? It will tell you. Give me some videos on quantum. It will tell you. So you will be able to go to Google, ChatGPT, and so on, and learn a lot on yourself as well. So this is what I wanted to really emphasize, that this is a very, very important aspect. And that's why I'm talking about quantum readiness. The number of people in India who really know this is still very small. You can try to estimate that. I tried to estimate how many people in India really know quantum at a serious level. Not the journalist who's writing an article on National Quantum Mission. That is just taking the press release and writing. So I tried to say how many schools, colleges, and how many in schools we are not teaching, how many universities and colleges are there. In that, how many have physics department? In that, how many physics department have a professor or teacher who knows quantum physics, who has done PhD in quantum or allied? You will see the answer is just a few thousand. The total number of people knowing quantum is a few thousand, unlikely to be more than 100,000. You just imagine the opportunity that is available because investment, and it is not only that. What is interesting is, unlike when we were young, when these things were done only by research organizations, maybe DRDO, CSIR, this, that. Today, private companies have gone into it. The same companies, IBM, has actually, you can just Google for it, IBM has announced that today it has launched a 433 qubit computer called S-Pro. It will now make 1,000 qubit computer by 2025, then so much, and so on. Google has this plan. Amazon has this plan. All the major computer companies have public plans about their progress in computing, quantum computing. And that is why it is a very important thing to look at. But another important thing, and especially in a forum like this, we are proud Indians. And I therefore want to tell you about the Indian tradition in quantum. Now, most of us have forgotten, though you know this, that Sir C.V. Raman got a Nobel Prize in 1930. We celebrate February 28th or something as National Science Day. He got the Nobel Prize for quantum, whereas Compton had done something called Compton scattering, which is a quantum phenomena at the level of X-rays. C.V. Raman did it for visible light. And Raman spectroscopy is a very powerful tool, which is there, and he got it in 1930. with Macaulay education and everything. So there was this thing. There's another very well-known Indian who contributed to quantum, who's very well recognized. His name is Satyen Bose, S.N. Bose. In fact, half the particles of the universe are called bosons.
But I
And
think
Higgs,
he didn't get the Nobel Prize.
he did not get the Nobel Prize. Yeah, that's the unfortunate part.
Yeah.
Not only he did not get the Nobel Prize, he did not even get Bharat Ratna. C.V. Raman got Bharat Ratna. But this is Takdir. So this we will take you to astrology and why your horoscope was such that in spite of that. But his name is taken together with Einstein. The phenomena is called Bose-Einstein condensation. People who did that phenomena, Bose-Einstein condensation, got a Nobel Prize. Higgs boson discoverer Peter Higgs got a Nobel Prize. But he was an unfortunate person who did not get the Nobel Prize, but his contribution to quantum is there. So I'm talking of India's contribution to quantum. And there is another third, even less known person called J.C. Bose. J.C. Bose was the first one to talk about physics of plants and the behavior of plants of this thing, and which I suspect he had actually identified quantum behavior in plants as well. But he is also something not talked about. But I'm trying to say this is because it is inspiring to know that these people have been there for a long time. And if you think I'm only talking ancient history, I want to share with you a name called Love Grover. Love Grover is a relatively young person, compared to us, who is from Delhi. He studied in IIT Delhi also, and so on. And he is famous for something called Grover's algorithm. You can Google for it, and it is a quantum algorithm. There are two famous quantum algorithms today. One is due to Peter Shor, called Shor's algorithm, S-H-O-R, that is the name. It is not noise. It is Hindi wala Shor nahi. Its name is Shor. Peter Shor's algorithm, that is one quantum algorithm, and Love Grover's algorithm is another. So it is likely that in the next few years, you will hear this name more and more as quantum computers become more and more available. So I wanted to say this to instill the pride that we can do this, and we've been doing this, and so on and so forth. There's a whole lot of other possibilities, applications, and so on and so forth that are there. And the thing that I want to share with you, and I think Dr. Gulshan Sharma had posed this comment to me before we started, the world is on a quantum race. Now, just like India created a national mission, US has also created a similar mission. And for example, all of you who are associated know that there were long ago, there were only few branches of engineering, like civil engineering, then came mechanical, then electrical, then came electronics, then textile, then chemical, then computer engineering, and so on and so forth. In electrical, it happened high voltage engineering, microelectronics, and so on. What is now happening is USA has recognized that last year they have persuaded their universities to start giving BTech programs in quantum engineering. In Australia also, University of New South Wales has created a program on quantum engineering. So the young students who are studying in your school or are your nephews, children, etc., they can aspire to do a BTech in quantum engineering in the future. And in India also, maybe BTech in quantum engineering will start coming. And just like the IITians benefited from the things that they learned, these people who will study quantum engineering or quantum physics, or etc., will benefit in their careers because there are so few. What is interesting is that now there are more quantum people in the private sector than in the universities. Because private sector, there has been a lot of investments. So all these venture capitalist investors, so they're making investments in quantum companies. And therefore, they are hiring professors and people who are familiar to come in and train their team and tell others. In fact, a lot of European professors, European elderly professors who know computer have all gone to US in startup companies. They're all in startup companies telling the startup teams what quantum is, etc., etc. and so on. So they won't remain only in IISc, Bangalore, IIT, etc. They will all go away because we are now coming to the benefits of that. There is a whole, now what has happened is, unlike computers, where the most computer technology is binary digits, bits, is silicon based, is on chips and integrated circuits and so on and so forth. We still don't know what is the best method for the core of a quantum computer, which is called the qubit. Now, in a normal computer, we have a bit which is a 0 or a 1. So such as the on or off, 0 or 1. A quantum computer qubit is what is called a superposition of two states. It can be both 0 and 1. It is actually a linear combination of zeros and 1. And that's why it is called qubits. So at the first level, a normal computer is bits. A quantum computer is qubits. A normal computer has a normal programming language. A quantum computer will have a quantum programming language. So just like you have Fortran, COBOL, BASIC, Pascal, Python, this thing, quantum computers have Quisquit, etc., other languages. Some programming can even be done on Python, but that's and they will therefore have special algorithms. Now, the point now is nobody knows what is the best physical way of making a qubit. So various people are trying. Some people are trying superconducting things, something are trying atoms, something are trying something else, something are looking at phonons, something is looking at. So there are about half a dozen ways of saying that we will make our qubits in this way. But the problem is that a qubit is very unstable. Now, even if you recall, when we started doing computers were kept in air-conditioned rooms, etc., and who know detail, even though sometimes you have to cool from below, etc., etc. Today, you take your laptop anywhere, almost everywhere. You don't put it in air-conditioned room, etc., etc. So same thing with happening with qubits. They're now looking for how to have more and more qubits and stable qubits. And one of the problems is error reduction. So that what happens, you may have 1,000 qubits, but only 300 are working, 600 are not working. This, that. So all these technological challenges are there. And that is why it is so exciting. That is why it is so exciting, because people who will create the best quantum computer will become very important. Just like, Intel, etc. became, there were so many chip manufacturers. When Bardeen made the semiconductor, etc., and there were Shockley, etc., they made this thing. But eventually it is Intel and a few companies, NVIDIA, there's that, who make chips. So similarly, out of these various companies which are working, a few will emerge as the dominant companies making these chips. Today, all these chips have to be kept at very low temperature, not ordinary air conditioning. They have to be kept at almost absolute zero. Now, if you know your physics, absolute zero is minus 273 degrees centigrade, only somewhere in outer space, etc. So when you see a picture of a quantum computer, you will see something big, chandelier-like. That's the cooling. The chip itself is very small. The quantum chip is very small, but it has to be kept in a huge thing to maintain the temperature of minus 273 degrees. So this is where it is. So now the race is on for the best chip, for the best programming language, new quantum algorithms, new applications. Now, what quantum computers are capable to do, and this word has been now accepted, is called quantum supremacy. So quantum supremacy is a word which has been created by John Preskill, who's a professor of physics at Caltech. Caltech is the place where Richard Feynman was there, who for the first time gave the idea of a quantum computer. The even idea of a quantum computer came on in 1980s. When Feynman said, he was kind of telling people like me that you don't try to do quantum problems on a classical computer. It will never happen. It will never be good enough. You have to make a quantum computer. So it is in 1980s that the quest for a quantum computer started. Now they are working. Many people are moving towards it, but still it is nowhere near the real quantum computer that we hope to get. But people speculate that between 5 to 10 years, it will become commonplace. Then it will become like a desktop. Everybody will have a quantum computer. And quantum supremacy was the phrase given by John Preskill to solving some problem which no classical computer can do. And Google actually hastily around 2019 end actually announced that there is a problem that they created. It was an artificial mathematical problem, not a problem of real world, some artificial mathematical problem. And they said their quantum computer did it in a few seconds, whereas the fastest supercomputer in the world would take several 10,000 years or so to do it. IBM, of course, contested it and said, no, it won't take that long, etc. But these are all quote unquote theoretical things, that how long does it take to a difficult problem? But people want to know how quickly it will solve real problems. What are real problems? Real problems are climate change. Real problems are precision agriculture. Real problems are new drug discovery. You know, I will share with you something. You may find it very, if I say that quantum computer has of great relevance for agriculture, you will say, how could this be? What is the connection between agriculture and quantum computer? And I will give you an example. You have heard that India achieved the Green Revolution, and you must have heard of Swaminathan's work and IARI work and so on. What happens is that when you take any plant, but take some grains, and you crossbreed them, then a better variety can emerge. So it happens in fruits, it happens in plants, it happens in grains. And you can, by doing this crossbreeding, which is what is done in agricultural institutes, you are able to get a grain which has a better quality, which you like, less gluten, more protein, this, that, disease resistance, so on and so forth. But today, the only way you can do this is by hit and trial. So you do the experiment, put it, look what it turns out. Do something else, look what it turns out. So you will see in Agriculture Institute, there are a large amount of farms which are experimental farms where they're doing this. But eventually what is happening, it is the genes. And if we know the genes, and we have quantum computers which can calculate, it can see what are the different combinations, permutations that are possible, and which of them are good for me, which of them are bad for me. The same thing is happening for drug discovery. When you take a new drug, you want to see what are the side effects, what are the counter effects, what are the good effects, etc., etc. And if you can do that faster, your new drug development becomes easier. New vaccine development becomes easier. We saw with the COVID, it took a couple of years to find a vaccine. Even then, there were so many things. If I could just calculate that with a quantum computer, I would get the answer much faster. And this is why all these people are investing in it. Because the big problems, the difficult problems of climate change, precision agriculture, new agriculture, health, etc., hope to get solved when we do this. Now, you may find it a bit overwhelming to understand. I will try to give it with a simple example, an example that I like. So what we are talking of, two systems of calculation. One is the traditional system, and one is the new quantum system, which you don't fully know now, but you can know with some effort, going to university, college, etc., etc. I'll give an example of why the system becomes so important. Now, all of you know, and I will revise it for you, that roughly the distance of the sun to the earth is about 93 million miles. And the speed of light is 186,000 miles per second. So the question is, how much time does light take to come from the surface of the sun to the surface of the earth? I'm deliberately saying surface of the sun to the surface of the earth because the photon from inside the sun to the surface can take a long time. There's a whole amount of nuclear physics in it. So let us imagine photon has come to the surface of the sun, is coming to the earth as 186,000 miles per second. How much time does it take? Very good. Either you remember from your school days or you write it 93 million, divide by 186,000, cancel the zeros, you will get 500 seconds. You can do this in your head or you can do it with a piece of paper. 93 million, 93, 6 zeros, downstairs 186,000, 1,000 cancel. 93 180 come 2,000 upon 2, 500. 500 seconds, 8 minutes, 20 seconds. Now, you may remember this from school. You can do this calculate with piece of pen, pencil and paper, or you could do it mentally like what I did. But you get this answer. But now, for all of you who have been to school or are connected with school, recall how in school you write class 5 as V, class 10 as X, class 11 as 10, X and 1, class 4 as 1 and V. Now write 93 millions according to this Roman arithmetic. Write 186,000 according to Roman arithmetic and try to divide. You can't because zeros don't cancel now. Now you will have to keep on subtracting 500 times in Roman arithmetic if you will be able to do this. That is why India was so ahead in astronomy. We could predict the ellipse, we could do this because our arithmetic allowed us to do that, with the Roman arithmetic didn't allow. It's the same difference between quantum computing and traditional computing. Quantum computing will be able to do a lot more than traditional computers let you do. And that is why there is big rush. And that is why we need to do this. I hope I have generated some interest in the whole topic, and we have some time. So I will encourage you to make your comments, questions, observations, and so on and so forth, so that we can do that over the next 20 minutes.
Wonderful, wonderful. It's so stimulating. It's so stimulating. Actually, people are just writing wonderful, amazing, great insight, valuable. Greetings from Tripura. It's so interesting, very interesting. I was looking forward to some questions. But sir, I don't have question. I have only compliments. I have only compliments. I've got.
Yeah, you trigger them. You trigger them to ask a question. If they ask a quick question, I'll respond.
Okay.
Yeah, because then only it will become interesting.
Yes,
because, yeah.
yes.
So
what we will do? Let's give some stimulation from our side also. The
yeah.
good 3 question will fetch you 1,000 rupees each.
Array.
Let's the good 3 questions will fetch you 1,000 rupees each. It should be relevant to today's topic. It should be something very, very interesting, inquisitive, which should trigger something like, I noted down on my notebook, the sunlight and how the light and 500 seconds and all that. And then the Roman part, we never observed, because those are not people like me, those are not from science background. We have never observed the things that way. I mean, it's so enriching, it's so engaging and so stimulating for all of us. Come on, let's have 3 very interesting questions. I encourage you, and Professor Pant sir will decide the 3 best questions. Let's have it. And we will give you 1,000 rupees award. Now, whether Sakshi or Anjan or Rosie Chakma or Anand Mukherjee or Kim Kipgin or Julie Subba or Deepa Hazarika or Taso Taje, I'm say, or for that matter, Dusu Nomo, Radhe Opo, Mohit Chaudhary, Habung, Rahul, and all my other dignitaries, those are right over here. Let's see if you have got any question to ask from sir. And by the time you think about and you come, would you be kind enough, sir, to tell something little more?
Yeah, sure.
They pick up their mind.
So,
I wish to know a little bit, sir.
Yeah.
How do you look at it? You have given something, National Quantum Mission, rupees 6,000 crore being allocated by the government of India. Sir, where do you see what China is doing, what US is doing, what Australia is doing, what UK or the rest of Europe is doing? I mean, sir, how are they moving in this particular subject, sir?
Yeah, so they're all moving with high speed and a commitment. And not only that, in many of these countries, it is the private investors who are putting a lot of money as well. Okay. Apart from government, private. So, for example, chasing a quantum computer, everybody is doing.
Okay.
In the UK, for example, they're doing another very interesting thing on quantum sensors. So today, for example, when you want to know anything that is happening under the earth, you need to start digging.
Okay.
Now with quantum sensors, you don't have to dig. So they're saying, let us look at London and we want to see what is under London, your whole underground, so many things. Now you can't keep digging it, right? So one of the things, so in quantum thing, quantum sensors have become a very important aspect because, as you know, the force of gravity is exerted everywhere. So if we measure the force of gravity and then try to find out what is there, which is what is done in oil, this thing. Oil companies do this. They try to find out whether there's oil inside. Mineral companies do this. BHP, Billiton, Rio Tinto, all these people, they try to see whether they are minerals. We also just now found lithium somewhere in this thing. Now, yeah. So now if you have quantum sensors, you will be able to see this much more easily. So that is another aspect. Very important aspect, which should be interesting to everybody, is also going to be the quantum internet and quantum cryptography. And I will explain a little bit about quantum cryptography. So firstly, everybody is doing this thing. Everybody is on search for a better quantum computer, better this thing. But some are looking at quantum biology, some are looking at quantum sensors, some are looking at quantum materials, and so on and so forth. But one very important aspect is coming, that is quantum cryptography and the cryptography that exists. So today we know that most of the data that we have on computers is kept in an encrypted form. So you encrypt it, and those who have the right key decrypt it. And the method that is used for encryption decryption is something called RSA. RSA is for Rivet, Shamir, and Alderman. These are the three people who created this. And the RSA algorithm is based on the principle that it is easy to multiply two numbers, but it is not so easy to factorize a large number, especially if the factors are prime number. So what RSA had done, they had taken a 64-digit prime number, a 65-digit prime number, and multiplied these two to create a 129-digit number and put it on the internet, say, who can factorize this? And that was called RSA 129. So with a lot of cooperation around the world, it was factorized. And so now what people use is RSA 2048 or some such large thing that the precision computers cannot factorize over a period of time. But Shor's algorithm can factorize any number using a quantum algorithm. But luckily, there is no quantum computer yet which can do it.
Okay.
So now we are talking of, so people are using the word Y2Q, just like they used to use Y2K for the year 2000. Y2Q is years to quantum. So when this quantum computer comes, all security will go for a toss. All blockchain will go for a toss. All blockchain is based on this. So now people are looking at post-quantum computer security. So what will happen when computer algorithms actually are there? Then we need new security because this method will not work. So that is going on. It's called NIST. So US, you are saying what is US doing? One is NIST. It is trying to get a lot of algorithms which are going to continue to be okay even after quantum computers are there. So this is the kind of excitement. So the China is doing a lot on the quantum internet. So one of the problems with the quantum computers is that the quantum state cannot be copied. There's what is called a no cloning theorem, because if you try to copy it, it changes, disturbs. So the way to take these messages, that's why they're using satellite rather than fiber optic, etc., etc. So that's another interesting area, quantum internet. And then there are quantum materials. So even the Indian mission has four portions: quantum computing, quantum internet, quantum communications, quantum materials, because people expect that some quantum properties can be very interesting. So you remember I told you my PhD was studying the quantum properties of solid state physics. So there is a phenomenon which many of you must have heard about called superconductivity. So superconductivity is something where a material has zero resistance or close to zero resistance. Now, superconductivity has been observed. Of course, Nobel Prizes, everything has been given, but they were again at very low temperature, close to absolute zero. Therefore, work has been going on getting superconductivity at room temperature. If we can get superconductivity at room temperature, then all these bullet trains will become maglev trains because they will move with magnetic levitation and you will have magnets on which trains will go. So this is what the hunt for superconductivity is. And there is a hunt for room temperature superconductivity. It has been achieved, but unfortunately, that room temperature superconductivity happened with very high pressure. So they're still waiting for superconductivity at ambient temperature and ambient pressure, which can be done. And it's basically a quantum phenomena. So actually, Bardi and Cooper Schrieffer got the Nobel Prize for their theory of superconductivity, and that is a quantum phenomenon. So this is another aspect on which people are working. And there's a lot of things in quantum biology. I mentioned to you about photosynthesis. So people are looking that if, for example, they can understand how photosynthesis is done and create similar method of producing solar power, then the efficiency will be a lot more than we have today. So today we have two ways of getting, one is solar power in a more efficient way, one is thermonuclear fusion. Both of them are quantum phenomena. And this is why the worldwide interest in quantum. So it is now, after the nuclear race, the space race, it is now the quantum race.
Wonderful, wonderful. Thank you very much, sir, elaborating that so well. One point which has just emerged, which you have made a mention, I want to educate myself. It may be useful to our audience also globally. Let's take an example of Shinkansen train of Japan. It runs at a particular speed. Now, when it leaves the railway station, the train gets little up.
Yeah, that's called magnetic levitation.
Okay, so it is electromagnetic field.
Yeah. So basically what happens is it is a magnetic levitation, but the amount, see, the problem is that those magnets are not as good as if they were superconducting magnets.
Okay.
So the point is that you have proved magnetic levitation, but still takes a lot more energy. So the search for superconducting magnets is that they will be able to do this with much less energy and therefore will reach a lot more places. Okay. So today you have these trains only in a few places because it's rather high-end technology and expensive and so on and so forth. But it relies on that principle of magnetic levitation.
Okay. And you use the term superconductivity, zero resistance. Zero.
So typically superconductivity means, see, normally you remember Ohm's law. Ohm's law says voltage upon current is resistance, right? Now, if this resistance becomes zero, that means the current will be infinite. And therefore there will be no loss of energy, etc. So that is why they search for superconductivity.
Okay, wonderful.
And it is now understood. So the science of it is understood. The engineering is what is all about.
Sir, in spite of my great temptation being given to the audience, I'm not getting questions. They are enjoying.
I think they're in. What happens is they are intimidated by the term quantum.
Yes.
So because if I were there, I would say all this is fine, but what the hell is quantum? Quantum of what?
Yeah.
Right?
Yeah.
But the point is sometimes they get intimidated and therefore they feel that we can't even ask a question. But the first question which anybody should have asked, so this is quantum of what? Ye quantum kya hai? So let me now respond, since I've asked this question and you will give me that 1,000 rupees, so I can answer this question. So after all, what is quantum? So you see, in our time, it was not so easy to understand what is quantum. But today's children can understand quantum very easily because they understand what is a pixel. They know a picture is made of a large number of pixels. And they know that when they go into the detail, high resolution, they have something called pixelation, where they can start seeing the pixels rather than the whole picture. So from physics point of view, the reality is made of quantum. The world that we see is made of quantum. And each quantum is very small, 6 point this thing into 10 to the minus 34 erg second. So when you look at it like a detail, so a quantum is a pixel of something in physics. And that something is called action. Action is something which is erg into second. The unit is energy into time. So just like when you buy electricity, you have watt hour is your unit. The very small unit of that, energy into time, is called quantum. And when you are dealing with a few quantum, you are in a quantum mechanical state. When you're dealing with millions, energy into time, erg second. Now, when you're dealing with millions of quantum, then it is like a continuum. Then it is like ordinary matter. You don't see that. So this is why we so far saw that largely in laboratories, experiments, etc., and so on. So this is why, and Max Planck is the one who had coined this concept, because they were trying to understand something called black body radiation and so on. I'm not getting into all that detail. And then they found that it can only work if we understand that these energies are in certain states. You remember I mentioned to you that sodium light becomes yellow, this, that. So this light comes because the electron transitions between two specific states, which are discrete states. So in the digital world, we understand that because analog world is continuous and digital world is discrete. Similarly, the macro big world is continuous, but the small world is discrete. And that is the quantum world when there are certain discrete values and so on.
Wonderful. Sir, education is next to your heart. Children are next to your heart. Teacher empowerment is next to your heart. When we conclude this particular session, 3 things I would request you.
Yeah.
Number 1, your passion is and your vision is self-paced learning in future, and
yes,
learning you always say.
Right.
What should be done in this quantum part at school level? What should be done at college level? And what should be done by youth and teachers as self-paced learning level?
Yeah. So my view on this is that just like if you recall that in schools, whenever you studied something beyond academic, there was a group created for it called a club. I remember when we were young, Aero Club was a very popular thing. How to make aeroplanes, toy aeroplanes, make them run, etc., etc. So I feel that for a subject like this, there should be a kind of a club or a community that is created. And where all children explore and share with each other their exploration. Now, actually, in pedagogy, there is a well-known technique called a web quest. Web quest is a technique for learning where what the teacher says, and this was long before AI came, only when the internet had come, what they would say, they will say there is a certain problem which has been posed. Now, all of you explore, and then they give some guideline. Now you explore the internet, find out about it, then share it among yourself, then make a common presentation, and then people will discuss and ask you what it is. So this is exactly the way that can be done. So we can have a number of missions and give 2 weeks for the mission and say you explore everything. Fortunately, today now even ChatGPT is there to help you, and you can try to do that, and then others. And then once they can get an expert person or somebody to guide them, encourage them, and so on. And since people like to learn, it happens today. Now the beauty about AI is if you explore something, it will tell you 10 more things like that.
Yes, yes. That's lovely, sir. Yes, yes, absolutely. Absolutely.
So
Sir,
that is,
sir, my curiosity and maybe my devotion to my industry, you will call me selfish for tourism, but somewhere again I'll come. AR is there, VR is there, metaverse is there, we are talking about all these things.
Yeah.
How do I link quantum with tourism?
No, see, the point is that one of the things is that if you enlarge the concept of tourism
Huh,
to going beyond these things to the universe,
huh.
and since you are interested, I will share with you. Have you heard of Carl Sagan? Carl Sagan is a very well-known, this thing famous for a series called Cosmos.
Yes,
You
yes.
just watch the videos, Cosmos. Now, the moment you start taking, so I tell people a lot, nowadays, as you know, I am not able to get out of the house so much. I find it difficult. So I say I am a tourist in space. I am sitting on a spaceship and going entire universe, cosmos, and so on and so forth. And there you will see all these quantum phenomena. The black hole is a quantum phenomena. So if you're going to visit the black hole, learn about the black hole, you will learn about quantum, you will learn about information in the black hole, etc., etc. So tourism is not only physical tourism or seeing what we see around, it is tourism of your mind also. The frontiers of your mind, the frontiers of your knowledge, you just look at the cosmos. It is amazing. And there's a very nice quotation by Carl Sagan. You can Google for it anytime, called the pale blue dot. The pale blue dot. The pale blue dot by Carl Sagan is a very nice passage about how the Earth looks from outer space. So Carl Sagan had asked one of these Apollo missions to take a picture of the Earth from outer space and send it back. And it appears as a small pale blue dot. And Carl Sagan has a very nice thing on what that pale blue dot is. He said, this is our home. This is where everyone we learned has ever happened. All the good people have always, all the kings, all the conquerors, everybody has just lived on this planet, and so on and so forth. So the moment you start looking at from that cosmic sense, astronomy, astrophysics, etc., then you will realize. And it is actually, there's another very nice book called The Greatest Show on Earth. The Greatest Show on Earth. It is, again, a book on what the universe is all about.
Wonderful, sir. Wonderful, wonderful. There's so much because now I've got your vision, I've got your direction, and I think something I would like to link it over there in my tourism industry, because when you've talked about the Carl Sagan and you've talked, because already space tourism is starting. Space tourism is coming in a very big way, sir.
Exactly.
That is something very, very interesting. And the pale blue dot and the greatest show on earth, the book which
Yes.
you mentioned. And pixels, sir, which you were telling, you know how it is giving me curiosity as a non-science student.
Yeah.
Generally, we understand, किसी पिक्चर को लेते हैं, इसके पिक्सल फैल जाएंगे तो पिक्चर फटी फटी होगी.
बिल्कुल.
ऐसा बात करते हैं.
उसको पिक्सेलेशन कहते हैं.
अच्छा.
वही हम कह रहे हैं. तो आप मैटर का पिक्सल देखना शुरू कर रहे हैं, दैट इज क्वांटम.
ओके, मैटर का पिक्सल देखना शुरू कर रहे हैं,
दैट इज क्वांटम.
All my teachers and all my students, that is quantum. Okay. One of your very admirer who's very fond of you is from Delhi Tourism, Mr. Sushil Saxena. He writes, it's a privilege to have Sir M.M. Pant Sir ji, great speaker, love to listen to him again and again. I have also been privileged from USA, from Texas. Professor Vivek Shankar Natarajan has joined, and he says, what a great show by Professor Pant on this earth. He is writing over here, Vivek Shankar Natarajan ji. I'm so grateful. I'm so grateful. And when we conclude, sir, your concluding remarks, because I just don't want to go. I always feel that way. But something finally from your side, sir.
No, very simple. That try to get to terms with quantum in whatever way you can. It is not only for physicists, it's not only for technical. Tomorrow's media people will also need it. Advertising people will also need it, because that's what the world is about. See, there is this thing. So it is at whatever level. See, it's like relating to the world. So we all relate to the world at different levels. So some people are artists, some people are painters, some people are musicians, some people are this thing. All that I'm saying is that the interpretation of the world in terms of its constituents is not the Pancha Tattva, it is quantum.
Ah, wow. Tattva and quantum. Wow.
See, at one time we thought that Pancha Tattva explains everything.
Yeah.
Today we realize that it's more than Pancha Tattva.
Ah.
And it is this thing. Tomorrow something else may come up. It is not that full and final. See, this is the big thing about science, that we always improve upon what we have. So when our knowledge doesn't fit our mental model, then we improve the theory.
Lovely, lovely. So wonderful, such a enriching and such an engaging and such an empowering, and so much to learn from you. सर मैं आज आपसे ना कुछ भिक्षा में मांगना चाहता हूँ सर.
अरे क्या बात कर रहे हैं.
मैं आज आपसे कुछ मांगना चाहता हूँ. आप महीने में एक दिन हमको एक सेशन जरूर दीजिए. Sir, humanity will be benefited. Now my entire team from the chamber will work on to it. We will share this information with all of them. जिनको आपने बताया कि किचन में जाके नीली लौ से आपने येलो लौ तो कर ली खाना बनाने.
Correct. नहीं सही बात है. But this is the see what I found this as the simplest experiment to demonstrate quantum.
Yes. Lovely.
कोई लैब नहीं चाहिए, कोई कुछ नहीं चाहिए, बिजली भी नहीं आ रही हो तो भी कोई बात नहीं.
Wonderful. Sir, we are so indebted to you. Our deep gratitude and thanks to you.
Thank you.
And kindly accept my request. Once in a month, we must have a program with you, sir. And I personally feel, although the program will be dedicated to northeast part of India, but it goes global. I want everybody, but next to my heart, ladies and gentlemen, although I'm born in northern India, but I personally feel there is a lot which we have missed in the northeast part of India. Those children, those teachers, that humanity also needs a lot of from us. So with these words, let's convey our deep gratitudes and thanks and salutations to Professor M.M. Pant, sir.
Thank you.